All right, so today we have presentations by two of our members. So first up will be Jay Ranchod, and then followed by that will be Bryan Lewis. So Jay's going to tell us about a project he did, a Shiny dashboard to model predict college basketball games. So Jay, go ahead and share your screen and take it away.
All right, well, thank you, John. So my name is Jay Ranchod. I am a BI developer with Jonathan Rowe's companies. I believe last time I spoke to the group, I was a financial and operations analyst with Jonathan Rowe's companies. It's been a little bit of an update since then, which I'm very happy about. And thank you to everyone who's helped me grow my skill set to make that possible. So the first thing I want to do is just show the app, and then I'll kind of get into some of the procedures and what I was actually trying to do, and then kind of accidentally landed on this app. So really all this does is it takes certain statistical metrics, things that you would potentially be inputs into an AI model, and compares them across conferences. So here you can see on the left-hand side, we have the Atlantic Coast Conference, and then here on the right, we have the Big Ten Conference, and we are measuring how assists relates to winning percentage for the season for each of the teams in these conferences. And you can see here the blue dots indicate that the team did in fact make it to the NCAA national tournament at the end of the year in March, what we call March Madness, and a red dot means they didn't. And I'll go through a couple of these outcomes, and what you'll notice is there's really not any one great predictor of who's going to have a big winning percentage and be good at the metrics and make it to the national tournament. Now, there's some metrics that are kind of cheating, like I won't get into all of them right now, but why is this not playing nice with me? I'm going to run it from here, I think, because it was not playing nice. So what you'll see as we run through this is it's pretty chaotic, actually. And that's kind of one of the main themes of this statistical analysis in general, is that there's really no good way to get through all of this with one AI model. That's kind of the unicorn that we're chasing, right? Is one artificial intelligence model to predict perfect bracket. Not going to be done, unlikely to be done at the very least. So you can see things like field goal percentage, and then you can see like free throw percentage. You can compare all kinds of different.
Jay, can you share your screen again?
Did I stop sharing? I did, didn't I? Oh, that's unfortunate. So here's what the app looks like. There we go. So you can see there are all different kinds of metrics, and there are certain things where, you know, there's like net rating and some more advanced metrics where it's like, well, okay, sure, some of these are going to have nearly perfect correlations because it's like your point differential per 100% possessions. Well, obviously that's going to relate to win percentage. That really doesn't tell you a whole lot, but you can get a lot of these other more granular and easy to track kinds of things like assists, for example. And then I put most of the conferences in here that have multiple, typically we'll send multiple teams to the tournament every year. I did not put the MAAC in, which I think is either the Metro Atlantic Athletic Conference or the Mid-Atlantic Athletic Conference. If you're familiar at all with this year's tournament, then you'll know why I'm mentioning them. So I'm going to stop sharing. If I can get like a visual or verbal indication from the group, scale of 1 out of 10. Does everyone know how the tournament works?
I have no idea.
No idea. Okay.
I know nothing about sports.
All right. Well, I'll start with the basics then. So I'll reshare the screen here in just a minute. But the basic idea is there are 68 teams that start, and then there are 4 play-in games that start the Tuesday before the tournament. And so you get down to a final field of 64. And for every like bracket challenge purpose, at least that I'm aware of, you can wait until the final field of 64 is determined, and then you can, you know, place your bets or put your bracket into the field or whatever. Now, the way it's broken up is there are 4 regions, each with 16 teams, and each region has teams ranked 1 through 16. So you've got the 1 seed plays the 16 seed, and then the 2 seed plays the 15 seed, and then 3 and 14, and so on and so on. And then you end up with 4 regional champions. That's the final 4, and then they all go to the same location. They play 3 games and determine who's the national champion. Now, I'm going to get into some of the mechanics of the tournament later, but for right now, I'm going to remember to share my screen in just a moment, and then I'll kind of talk about the process of how I actually like pulled this stuff together first, just because that's actually where's my there we go. Sorry, I didn't find my Zoom icon for a second. So I'll go back to sharing here, And why is this not letting me share? There we go. Okay. So the process breakdown, I'll go back in a moment and talk about what I was trying to do. But what really happens is you start off with pulling tabular data from the web. And I did this with RVest. You can do it. You could just take the entire tidyverse, which is a larger set. RVest is like a subset of the tidyverse. I use RVest to pull tabular data out of HTML pages. It's what I learned first, so I just kind of stuck with it. Then you got to organize the data. This, I would hesitate to really go as far as to say this constitutes data engineering. Really, you're messing with it with dplyr and tidyr. And Brian, I remember I've been thinking about you a lot recently, Brian. First of all, I've been working with SQL a lot in my current job, and I remember our chat about SQL versus DuckDB and the opinions that you were discussing.
Well, DuckDB, you mean dplyr? Like DuckDB is a SQL engine, right? So dplyr is what I prefer to SQL, quite honestly.
Okay. Well, I've just when I'm at work and I'm cranking through SQL and I have a really obnoxious problem, I think I need Brian here to help me and just ditch this.
Just use dplyr. Just throw it over the fence to R and you'll be fine.
So dplyr and tidyr are really the packages that I use to do most of the, I'll call it data manipulation more than anything else. And then I've integrated it into the Shiny app infrastructure. If anyone here is not really familiar with Shiny's reactive architecture and how to set up an app, I'm not really going to go through the details of that tonight. If you're unfamiliar with that and you're interested in learning, I don't want to exclude you or like make you, just dwell in that space of not being able to figure out how things work. Please find me on the meetup page. Let me know. Let any one of us know. Or if you're unfamiliar with that, anyone here who knows is going to be happy to help you out. I promise. And then the last part of this is trying to get useful data regarding the tournament and how to predict who's going to win these games. It's difficult to do, and I'll talk more about that in just a moment. So pulling tabular data, I went to this page. This is sportsreference.com. And so what I did is I just cycled through each conference, and then you can see you get tables here regarding, you have to pick the season, and then you get tables regarding each of the teams in that conference and all of the different statistics really that you could possibly want. So that's all I really did was I picked the current season, and then it was just looping through each one of those. So that's what this looks like here. Path, extension, all looks pretty straightforward. All I'm doing down here is picking the third table of that link where I'm pasting the core link, looping through the conference, the season, and then picking the third table. Organizing the data, it starts with really, I don't mean to mix my sports metaphors here. I know I'm talking about basketball. I'm going to use the phrase blocking and tackling tasks. So kind of straightforward things that are important, but not really all that exciting. Selecting the columns you want, renaming the columns, fixing the data types. You can do calculations with numbers that were previously strings, all that sort of thing. And then wide versus tidy format is actually kind of a big deal for this app. It's kind of the main manipulation that makes everything work. For this purpose, tidy format is best because it enables you to make a copy of the data table and then filter it down on each table the way you want it to. And so this is just a really quick spreadsheet that I kind of tossed together regarding wide format versus tidy format. So there's, the metrics out, each metric has its own column in wide format. In tidy format, you only have the one column that has the values in it. And the reason that's helpful is you can make copies of this table and then apply each filter the way you want it. So you get one filtered data set over here, another filtered data set over here, and you can apply them to the different graphics. So that's exactly what this part of the project was, is each copy, you make a copy of the format, and then you have the two graphs like you just saw in the app, and you've got the metric filter, which controls both graphs, the outcome filter, which controls both graphs, and then the conference filter, which one graph goes to one filter, and that's how you compare the conferences. So that part was not, I thought it was interesting because it was kind of my first time doing that sort of thing. Those of you listening more experienced with Shiny apps are less likely to be terribly excited about it, I'm guessing. Now, this is what I would consider to be the really interesting part. So I want to, if you'll indulge me for just a moment of story time here. My previous job was at Epic Systems in Madison, Wisconsin, and I was working for, I was working with the cognitive computing team, the team making the inpatient AI models. And one particular March, I asked the lead data scientist, hey, why don't you apply some of these methodologies to the March Madness tournament and make a huge pile of money and then just quit? Not because I don't like you, but just, it seems like a good idea. And I was still learning about the finer points of machine learning at that point. And he just said, well, you can't do it. It's not possible. And he said, there's just entirely too much chaos in the tournament. There's so much unpredictability that no model is really going to be significantly better than a fan of the sport who fills out the bracket based on just knowing the sport and watching the season. And that really played out in spades this tournament. So I'm guessing nobody here really followed the tournament terribly closely. If folks aren't really familiar with it, the mechanics of it anyway. So to give you some framing for this particular season, there were 20 million plus, actually over 20 million brackets that were filled out this year. And I think the three main sources are ESPN, CBS, and Yahoo Sports. So 20 million plus brackets filled out. Does anyone, well, nobody's gonna, does anyone want to guess how many games into the tournament any perfect brackets lasted? All right, doesn't look like anybody's interested in being bold and taking a guess here. 28 games. So after the 28th game, there were no more brackets left. Or maybe it's after the 29th, but that's not even a first round.
What's a bracket again? What does that word mean? I'm sorry, that's a stupid question, but I'm not sure what it means, a bracket.
So sorry. So a bracket is you have a piece of paper, basically, or you can do it online. And it has all of the teams listed in their tournament format of who's playing who. And then you write on the lines going inward, I think this team's going to win. I think this team's going to win. And then you do that for the entire field of 64, all the way down to the final national champion. I'm not going to show mine because I don't want that atrocity on the internet. It was bad. I got my tail kicked pretty bad. So the game is there are what 60, well, if you take the final field of 64, there's gonna be 63 games. And then you say, I think these are gonna be all the winners. And so you ultimately get 2 to the 63 possible permutations, which is, John, I was just gonna talk about that. Nobody look at the comments. Okay, so, so that's the game is you have these 64 teams and you say, okay, there's 63 games and I'm gonna see if I can figure out and pick who's going to win each one. So and I'll just keep my face here so I can see you guys until I have to go back to the slides. So there were 20 million plus, or a little over 20 million of those. 28 games was the longest holdout. So I guess it was the 29th game that killed the last perfect bracket, which is not even the first round, right? There's 32 games in the first round. Nobody made it through the first round this year. And that's actually not abnormal. Usually it's somebody will make it into like the second round kind of, but then they get wrecked. So the big one that if you read the comments, you already know, there's a 15 seed from somewhere in New Jersey called St. Peter's. Yes, John, go ahead.
Hey, I think it would be interesting to look at like how different was the way it played out would be from sort of the a priori, like if you just bet on everybody's ranking, and then look some measure of how different it turned out, from that, and then compare across years, because it did seem like this year was an especially difficult year, and people did not do well.
Right, but you got to remember, it's been more recent years that the chaos has kind of been getting more and more vitriolic. If you remember, I think it was, I want to say it was like 2017 or 2018 maybe, that was the first year ever that a 16 seed beat a number 1 seed. University of Maryland, Baltimore County took down University of Virginia in the first round, and just the Virginia coach was really class. He was like really classy guy about it, and everybody else was just like crying. It was actually kind of funny. But anyway, in more recent years, you've seen more high seeds beat more low seeds. So that would actually be an interesting retrospective analysis. But in any case, this year, the big thriller was this small town school, St. Peter's University, beat number 2 seeded Kentucky, who was actually one of, I think they were the 5th favorite to win the tournament or something like that. So more people actually picked University of Kentucky to win the national championship than picked St. Peter's University to win the first game against University of Kentucky. So that's the kind of chaos that you're seeing. Also, just if you'll forgive a brief tangent, the St. Peter's Kentucky game was played in Indianapolis, and St. Peter's is in somewhere in central-ish New Jersey, I think. And so you typically in the first weekend you do 2 games, right? You do your first game, and then if you win, you play your second game 2 days later. So St. Peter's won their first game. Their dance team hadn't even gone out to Indianapolis because the school was just like, well, they're just going to be there for one. Like, it's not really. So they won the first game, and then the poor people in the dance team took like they took a bus from New Jersey to Indianapolis like the next day. And I just thought that was really funny. And another last funny anecdote. As University of Kentucky was losing, as St. Peter's was finishing out the 4th, I think they went to overtime actually, but at the end of the game, the St. Peter's University, St. Peter's.edu crashed because there was so much web traffic because nobody knew who these guys were. Everybody was like, is this a real school? Like, do these guys actually exist? And it actually crashed their website. I just thought it was really funny. In any case, St. Peter's went on to beat Murray State University and Purdue University, who's also a legitimate national title contender. And so my point in all of this is there's so much chaos here that trying to make any kind of comprehensive universal model to predict this thing is, at least as far as I can tell, unlikely to be terribly successful. So I'll go back to my screen share and just kind of go back to some of the points here. So that's the main reason, right, is the individual level chaos, by which I mean, I ran track and cross country at a Division III school in college, so it wasn't, high pressure by any stretch of the imagination. But I can tell you, sometimes you wake up in the morning and you're feeling great. Your coach says all the right things. All your buddies in a good mood. You get out there and you kill it. Other days you wake up on the wrong side of the bed. Some jerk down the hall was playing music all night. You put too much hot sauce on your eggs at breakfast or whatever, and you just have a terrible day. And there's all kinds of chaos like that in this tournament. Pressure of expectations. One of the big reasons that we've seen more of these 15/2 and 12/5 and 16/1 victories in the past couple of years is a lot of these coaches and players at these smaller schools are starting to realize nobody really expects them to win, right? Nobody thought St. Peter's was going to beat University of Kentucky. So they just go out there, they play loose, they have a good time playing basketball with their buddies, and they're feeling good. Kentucky's like, oh crap, everybody thinks we're going to win this game. So as soon as St. Peter starts sticking around for 20, 30 minutes of this game, they start getting more nervous, they start playing tighter, they start screwing up more, all kinds of things like that are really, really, really difficult to quantitatively capture. The other thing is the importance of features change, right? So what matters in the first round is very different than what matters in the third round. So when you have features changing like that, it's very, very difficult. And one of the things I recommend for anyone who wants to try this is to build a different model for the first round, build a different model for the second round, build a different model for the third round. You're much more likely to be successful doing it that way. Or you can analyze descriptive statistics, which is what I'm going to do here. So the whole reason I built this app is because I pulled all this data and I was going to try to make a nice, cool, interesting model for it. And then I realized that my associated epic was actually quite right. It's probably not going to work out very well. So I just made an app with some descriptive statistics in it. So as far as applying this goes, there's I want to give a couple of examples here. So number one, I'll show University of Notre Dame versus Alabama. So this is updated for the past season now that we've actually had the tournament. So if we look at the ACC, and I'll make this bigger so everyone can see. And let's see. So we've got the ACC versus the SEC. So one of the first things I want everyone to notice is University of Alabama plays with a very, very high level pace, right? So they play a quick tempo game here. And the reason that's particularly important in this matchup is University of Notre Dame was actually one of the playing games. So this is a first round matchup between these two teams, But in the span of 48 hours, Notre Dame had to play their play-in game, realize that they had won, and then they had to fly across. I think they were flying from, I want to say it was like Dayton to somewhere in California, and then play this high-paced game. So that's not a great formula, right? That's a pretty tricky thing to do. So the implication, sorry, I keep going back and forth here. The implication is that Notre Dame has to play with a very, very high level of efficiency. They have to be very efficient. And spoiler alert, they were. Notre Dame ended up winning the game. And I won't go through the statistics here, but I think they shot like 90% from the free throw line. They were, I think, you know what? No, actually, I will go to the statistics here because I completely forget what this is. But yeah, they were 62% from the 3-point line, 90% from free. I mean, that's absurdly good shooting. That's just incredibly good basketball, incredibly efficient basketball. So you wouldn't really expect that to play to Notre Dame's favor, right? They're tired. They've had this cross-country flight. They've already played this game. They're playing one of the high-tempo teams who's ranked higher than them. That doesn't look good. But you know, okay, if they're going to win, they have to be efficient. You can look at the app. You can see they actually do score fairly high in 3-point percentage. So you can kind of tell, okay, well, that's what they're going to have to do. That's what they're good at. Maybe they do have a shot here. And this is a quote from one of the Notre Dame players. We kind of rolled into California with that hunger. I think the quick trip actually helped us because we were still hungry. It's like we just got off the court, put us back on, we're ready. That's kind of hard to quantitatively capture, but if you look at the descriptive statistics, you can kind of see how there's a path to victory for Notre Dame. Second example I want to go through is Texas Tech, and I'll show this in the app when I'm done with the slide here. So Texas Tech, for those of you who aren't aware, widely known for their defense. That's kind of, they're a very talented basketball team in general, but that's kind of their thing, right? Very aggressive, in your face, high energy defense. Well, Duke excels in a couple of things. A Coach K team is going to excel at a lot of things, but specifically free throw percentage and ball movement. So if you're moving the ball well and you're taking advantage of the free throw attempts you're getting from this aggressive defense, then it's going to be a strength on strength matchup. Typically in that kind of scenario, the better disciplined, better coach team is going to end up winning. And if you look at, and I'll show you this here, we can actually see, if we look at the game cast for this game, that down the stretch, Duke actually kind of pulled away with it. It's a little last gasp there by Texas Tech, but it comes from making those free throws and having that disciplined ball movement. These are the free throws in garbage time here down at the end. So that's kind of how you use this app to pick, use it to determine what you think is going to be necessary, what the path for victory for each of these teams are. So I'll go back here real quick and I will show SEC versus ACC, and we'll go to 3-point. Where are we? 3-point shot percentage. And so if you look, you can see Notre Dame does very, very well there. And you can see if you look at free throw percentage, that Notre Dame does quite well there as well. So you can see, well, they're naturally a very efficient team. That means they do kind of have this path, and then you get that kind of more qualitative sentiment that you saw in the quote from that guard. And then if we look at, let's say, the Big 12 versus the ACC, we can see here, where's Duke? We can see Duke does quite well in free throw percentage. And if you look at, let's see, what is it? Assists. I believe you can see Duke does very well with moving the ball to the open man as well. So that's kind of how you determine there's that strength on strength matchup. A lot of this is difficult because you kind of have to know some dynamics of the game. So you need to know that Texas Tech is known for their defense. You need to know that Duke has one of the most legendary coaches in the game right now. You need to know that Notre Dame had their play-in game and then had to play the next day, and that, so there's some stuff that's not really quantitative that you kind of have to know if you want to really, engage with this kind of descriptive statistics process. There's nothing really, I can't really write an app to help you with that. ESPN they got a website to help you with that if that's what you're interested in. So the takeaways that I would want to leave everyone with, RVest can help you pull data from web pages. TidyR is also will give you all the tools you need to do that. dplyr and TidyR can help you manipulate your data into a desired format. And I spoke a little bit about the formats that are going to be a little bit better for kind of filtering down different copies and pasting them into this Shiny app infrastructure. And the final takeaway is do not quit your day job and bank on your bracket winning big. Unlikely to happen. I have faith in you. I have faith in the intelligence of this community. Generally, I believe you guys can accomplish anything you put your minds to, but maybe not this. So maybe there is a limit to my faith in you guys. So I know I said a lot there, touched on a lot of different R and non-R related topics. Does anyone want me to go back over anything, explain anything, any questions? Everybody want me to just shut up about basketball for now?
When you say betting on stuff, is that like Vegas or where, or is there?
I can do wherever.
Wherever.
So there are two main ways to do it. There's like the bracket pool way. So basically, I think you can score it in different ways, but the way I've always seen is like you get 1 point for calling a first round game correctly, 2 points for a second round game, 4 points for a third round game, and so on. I don't know if he's still doing it, but at least for a little while, Warren Buffett kind of had this thing where it was like, if you got a perfect bracket, he'd give you like $1 billion or something like that. So of course, you know, I'm smart enough, right? The other way you can do it, and there actually is a legitimately good way to do a game by game betting. So I read an article years ago about this guy who he did it in the NBA, not college, but so in pro basketball, what he would do is he would make these models and he would look for the biggest mismatches between his model and what the Vegas lines were predicting from like MGM or Caesars or whoever. And then he would just bet those mismatches that he thought were in his favor. And the deal wasn't, oh, I'm so smart, I'm going to win every single one of them. But the deal was, I'm going to pick the biggest mismatches and do my expected value calculations so that, you know, over the course of, you know, thousands and thousands of bets, I come out on top. And I thought, well, that's really cool. It sounds like a great fun, but an incredibly stressful way to make a living. And I decided it really wasn't for me. So there are a couple of different ways you can gamble on this if you are so inclined, although, you know, like I said, just be careful. Yeah, John and Alec, looks like Alec, why don't you go ahead?
Thank you. Thank you. Really cool. This is a very small detail, but I really like that loading animation for when it was like pulling data and stuff like that in the Shiny app. What did you use to make that?
Yeah, I can definitely share that. So that is going to be, let's see, where did I put you? There is, it's with progress, and then you say you have a message, and then you have your min-max loading. And so after each chunk, you can set the progress to some value within this range, and then you can update the loading message. And that's how you'll get the loading down there at the bottom.
Cool. What package does that come from? Is that a Shiny thing or something else?
That is a very good question. Let me see. I'm literally just Googling like with progress.
Yeah.
Let me see if I can find it for you real quick. It looks like it's just the progress package.
Oh, okay. Progress.
Yeah. Yeah, no, that was one of the cool things. I really wanted to have something that would actually do specifically that. And it took a little while to get it, to be honest with you, to figure out what it was and how to implement it. But I do it on all the apps I write now, and it's definitely a professional touch, I think, more than anything else. Yeah, John? Or is that an old raised hand from when you were, that's an old one? Okay. All right. Anything else? Going
Thanks
once?
so much, Jay. Any Jim, did
all
you
right.
want to ask a question? No? Okay. Nice to see you, Jim. Okay, great, Jay. If people have questions, other lingering questions, you can throw them in the chat. Next up, we have Bryan. He's going to talk about elastic computing with R and Redis. So take it away, Bryan.
There is a with progress in Shiny as well. So I don't know which one you were using, if it was that package or the one from Shiny.
It might just be embedded within Shiny, like part
Yeah,
of it.
yeah,
So,
but yeah, I'm not sure if they were different. But yeah, so this is kind of an old and a new topic. It's been lingering for years. A couple years ago, right before the pandemic, the last big conference I was at, I was talking with Henrik Bengtsson, and I were talking about doing something along these lines, and it, of course, never happened. And then more recently, I was contacted by some of the organizers of USAR to do something about this, to talk about this. And I couldn't make USAR this year, but it did prompt me to start working on it at least. It's not complete yet, but I can show you where I'm at. So this is kind of a back-end topic. There's no fancy graphics. In fact, there's no graphics whatsoever or any interfaces. In fact, these packages aren't even meant to be used by other packages. They're really just to help you do parallel computing in R. One of them is very old, and the other is so new it's not even fully on GitHub yet. So there's many dozens and dozens and dozens of ways to do things in parallel or in a distributed way in R. To do, let's say you have a computation that's really slow and you want to run it on a cluster, or it uses too much memory, and you're able to break it up and you can run it across different machines. R itself comes with the parallel package and many other ancillary packages. But there are two particularly important packages, in my opinion, that are kind of overarching. And those are the foreach, which is an old package that an old colleague of mine, Steve Weston, wrote in 2008. And the future package, which has still been around for a long time. That was written by Henrik Bengtsson, but it's more recent. I think it dates back to about 2012. The important thing about these two packages is that there's a clear separation of intent between how the parallel computation works. The problem with the parallel stuff that's baked into R is that if you use that stuff in a package, you've made a decision as to how something should run in parallel, and that may or may not work for the user of the package. And it gets much worse, of course, when you're using esoteric things like MPI or whatever, or Amazon. And so the philosophy behind both the foreach and the future package is very simple. The package author, somebody who's writing, usually some computational or analysis package, makes a decision about which parts of the code that they're writing is able to run in parallel, and they mark that. And then the users of the package, the people who are actually running it to do their analyses, they make a runtime decision based on their circumstances on how to run stuff in parallel. And by separating those things, you can gain the flexibility to run distributed computation easily anywhere, from across a couple of laptops all the way to on top of supercomputers. And both of these packages follow that philosophy in slightly different ways. And then I was interested in, I worked with Steve on the development of foreach. And then I was also at the time very interested in elastic computation. Amazon was relatively new in the late 2000s, or at least their elastic compute facilities were. And so the idea behind the elastic part of this is you want to run stuff in a distributed way or in parallel across multiple R worker processes, but you want that pool of workers to be completely dynamic so that you can make a choice to add more capacity, like on Amazon Spot Market, for example, when it becomes available, or remove that capacity, also like on Amazon Spot Market when it goes out of price. And that should be completely dynamic. So workers can be added and deleted at any moment. And the next thing that you need for elastic computing is fault tolerance. I mean, fault tolerance is nice fault tolerance means if something crashes or doesn't finish, the stuff it was working on gets rescheduled. And you kind of need that if you're going to have an elastic pool of workers, because if you turn some of them off, they might be in mid-computation. So if they were working on something and it was lost, you want to be able to have that resubmitted and rerun. And portability is also important because you might be running on just a bunch of weird stuff. I keep hitting the wrong key, sorry. So I wrote doRedis in 2009, just a few months after Redis was published, actually. So it goes back a long ways. The first version used, it has changed over the years. Originally, it was my own implementation of using just native R to communicate with Redis, but that package has been deprecated, and now it uses, since about 2018, it uses the Redux package to talk to Redis. For those of you who don't know what it is, Redis is it's a key value database that is super popular, and it's mostly used for caching, but it has a lot of pretty amazing capabilities. And one of those capabilities is you can define queues in it. And so doRedis and the other stuff I'm talking about today uses that basically to set up task queues for the work. And the nice thing about the doRedis package is that even in 2009, I wrote these scripts to work with like the Amazon spot market so that you could set up Amazon instances that could just be turned on and run and turned off. And they use the kind of the way Amazon has this kind of bizarre, very odd way to pass runtime configuration information to instances as they're starting up. And it uses that to get the configuration information. And those scripts are ancient, but they're still work. And it's fairly popular. I know of a couple sports teams have used it to run their large-scale R analytics in a couple of cases. And the biggest deployment of it that I know of is there's a stock exchange that's using doRedis to run large-scale Amazon R jobs regularly. And that'll, depending on the work they're doing, they'll run anywhere from a couple dozen to a couple hundred Amazon workers dynamically to run some modeling in R. And they run that every night. And I know there are many other users of it. And okay, so yeah, so finally it's the right screen. So before I move on, I guess I'll just show you how it works. Just a quick example. So can you see these terminals? Can you all see it? There's three. John, anybody?
Yeah.
Yes? Okay.
Yeah, we can see it.
Over on the one on the left, the white one, I'll just start up an R session and I will load. How much time do I have? doRedis. So I've just loaded this doRedis in R and I will register it with a queue name. I'll just make up a queue. I don't know. Okay. And then now, so now I will run some work. If I just do this, so I'm not actually going to run a for loop. I'm just going to run something multiple times. That's what that times function does. And the doRedis package has this kind of odd operator way of invocating starting stuff up. But if I just use that operator do, I will just get, here, let me run this session info running. This is just going to repeat that command, session info, twice and return the result in a vector, maybe, or a list, a vector. Okay, so that's the machine I'm running on here, my little laptop, just ran it twice. If I change the do to a do par, it'll run it in parallel using that Redis backend that I registered with a queue called hello. And nothing happens. The reason nothing happens is because I have no remote workers listening for work on that queue. So the cool thing about these job queue systems is the number of systems that are running the work that you dole out is completely dynamic, which means it can be zero, in which case I'm just blocking until somebody comes along and is willing to take up the work. So I'm going to manually start up another R process again on this local system here. And instead of here, I'll do what is it? Redis worker, the queue name. Where did I call it? Hello. And what do I want? I want. I'm just setting a few manual things here so that we see what's going to be happening here. I'm turning some logging on. And you can see some messages came out. It took these 2 jobs from and it returned its result. So just to show that it can be pretty bizarre, this lower right terminal window is on a Windows laptop. So I'm going to start R over there, which is pretty. I'm not used to using Windows. Oh. Okay, so it's a different version of R. And let's see, library, do Redis. So this is showing kind of both the distributed nature of it and the portability. Redis worker. Hello. That should sit there waiting for work now. And if I run this again, it should run across both of those systems. Sometimes, there you go. One of them ran on one machine and the other task ran on the other machine. So you see I'm getting back 2 different systems, a Windows 10 build and a Dev 1 Linux build. And so here I'll show you, let me just really quickly show you one other very brief example. I'm going to put in front of this stupid little example, I will put in a sleep so that it'll take, I need about a few seconds here. I'll do 5 seconds. So I'm putting in this sys sleep. So they'll sit there for 5 seconds and then they'll return what they're running. And I'm going to crash this one intentionally. So that one in the top right, I just stopped R. I just quit R. I hit Control C and crashed it. And you can see now, this is not instantaneous. There's some timeouts and like it's waiting to see what's going on. But eventually, we should see a message. Oh, maybe I didn't turn on verbose. Let's give it a moment. Just give it a moment. It should recover from this fault. We'll see. There we go. It's unhappy. And they both ended up getting run on the Windows system this time. So it detected the fault in the failed task. And you need that when you're dialing down workers like so I don't know if anybody here has ever run the spot market on Amazon, but they'll just cut you off sometimes. Like you'll be running stuff on a spot machine and it'll just go away. So the only real way you can safely run stuff, I shouldn't say the only way, this makes it really easy to run stuff in the spot market on Amazon. Okay, so that's enough of the demos. I'll go back to the 2 slides I have left. So Henrik Bengtsson has this beautiful package called Future. It's a bit more modern. It's very different than foreach, but they do the same thing. They both have this concept of you want to run stuff in parallel, and you want to have package authors say, this part of my package can run in parallel, but the users to say how they should run in parallel, right? Because, I've got a handful of laptops here, but like some other user might have, a giant Amazon system or running on the Amazon spot market, or somebody else might have a supercomputer. They may have completely different settings and they want to run their stuff differently. So both of these systems do that. Foreach is an all-in-one kind of deal, though. It's not just, so foreach does a map reduce all in one step. So Steve probably should have called it map reduce, but you can supply a reduction function with it, and it'll map data across an R expression and fold the results through a reduction function. for you. And it can do that out of order or in order, but it's kind of an all-in-one solution that does everything. Whereas future is a much more generic approach. It's extremely low level, but it lets you do anything. So instead of having one system with a specific syntax, you can use Henrik's futures in any context. Like you could use them in MapReduce, you could use them in lapply, in any of the apply style functions. You could use them in for loops. You could use them with the per package or the fur package. You can use them in really in any context. So they're completely generic in that regard, which is super cool. A consequence of that is that the for each side of things is job oriented. So it kind of, the way I wrote the doRedis package, the queue is set up to process a collection of a bunch of different tasks all at once, and it knows that they belong together. Whereas the future package, because it's so generic, is specifically task oriented. So I'm having to re-architect the backend system for it so that each task can, for instance, learn how to handle its own faults without having the context of a larger job. And what I mean by pipeline folds, that's an important thing that you get for free in for each, as data are coming back from parallel workers. Like they're not going to be computed. Let's say you're running a huge computation that's got 10 million iterations of something, right? Or 10 million things that you're processing separately. And you only have 10 computers, right? So it's not all going to come back all at once. You're going to start getting the results dripping in, and for each can fold those as they come in, either in order, or out of order. If order is unimportant, if you have a commutative operation, whereas you can do that with future Redis and the wrapper functions like fur and. Well, I don't think they actually do that. They actually take all the results first and then apply their reduction to it right now. But it would be possible to do that. It just hasn't been written yet. So that's something I'm going to be working on. My goal is, what I'm working on right now is this future Redis. And my goal is to achieve parity between the two systems, so that if you're using future, you can use future.redis. If you're using for each, you can use doRedis, but they'll basically be functionally equivalent. And where am I at? I have a skeleton package that's almost ready. I'm just working on some C code. There's some tricky threading that you have to do in order for the fault tolerance to work, that I'm just kind of finishing up for the future Redis package. But so it's not, there's just a stub on GitHub, a placeholder for it, but within a day or by the weekend, I'll probably put like version 0.0 of the package up there. And if you're interested, you can help me. I would love help, just people playing around with it, testing it, breaking it, documenting it, adding tests. There are also some design, there's a design document that compares in detail the two systems, for each and future, and there's some efficiencies that I get easily in for each that are not as easy to do in future. For instance, really quickly, what time is it? Oh yeah, I got a minute. So for instance, the doRedis package, the global, let's say if you're over here, let's say over here, I define a variable, x equals pi. And then I run an expression that uses x inside this expression, these curly braces, and it's going to run on that Windows machine. I have to get the value of that variable x that was defined over on my Linux machine over here across the wire onto that Windows machine. So that's some lexically scoped state that needs to come across and go to the other machine. And the future package and the for each package handle that for you automatically, which is nice. Both of them do that. The for each package, though, I get some clever efficiencies out of it, because all of the lexical scope that's shared between a bunch of tasks within the same job is never repeated and only downloaded by each worker process at most once. And so, it kind of minimizes network traffic. And I haven't figured out how to do that yet in future, but it can be done. It's just a matter of code. Somebody has to figure it out and code it up. So I'm looking for clever ways to gain some of the efficiencies I get in foreach, but in future. And then the AWS scripts that I wrote that amazingly still work were written in 2009, before like systemd existed. So they use the system 5 in it. They're like really old, right? But they still work. I mean, you can use them. But I would love help updating those to, match what people are actually running these days on Amazon. And I've only focused on Amazon, but there's other cloud service providers, right? So if you want to run the stuff on Google or Azure or whatever, and you could contribute these scripts. These scripts are not installed by the package, but they're in some, installation directory that you can look at and manually use them, right? They're just extra data in the package that'll help you set up these instances. Yeah, so that's an old package and a new package that both do the same thing. Very sophisticated and extremely general parallel and distributed computation for R. So there you go.
Very cool. Thanks, Brian. Does someone have their hand up? Yeah, Alec, go ahead.
Thank you, Brian. That was really cool. With I'm guessing 3 machines that you were running for the Redis example.
Actually, two Linux ones were the same.
Hey, Brian, can you stop sharing your screen?
Oh yeah, sorry.
Yeah.
How do I do
you had it.
Yeah. Sorry. Yeah, there we go.
How did well, at least the Windows machine, how did that know what was available?
Oh yeah, that was I did that start. I was doing a manual incantation of the starting a worker, and I used the same key name that I was using in Redis. They both had access to a centralized Redis. Redis is a networked key value database, right? It runs on a port on a network. Both of those laptops could see the server. It was running on my Linux laptop, but they're on the same Wi-Fi here, so they could see. Yeah. See it. And it's not firewalled off.
Okay.
So I specified. I just used the default Redis port, and I actually tunneled it to the Windows machine. So thought it was running on localhost, but
Okay.
But I specified the queue name, right? So I've got a task queue, or in the case of doRedis, which I was demonstrating, it's a job queue. So Redis has this cool thing called it's a key type, or it's a value type, I should say. That's a queue. It's like a first in, first out, or actually, it doesn't have to be a FIFO. It could be in any order, really. But it's a messaging queue basically, and so you can push and pop data out of it, and that's how I send the tasks out. But that was labeled. So the idea being, you're somebody and you're running tasks. You would pick the name of the queue that you want to use in your Redis instance. That if it's a shared Redis instance, you would have to come up with some name for your queue, for your work queue.
Yeah. So to be clear, there was just a bit of a setup that we didn't see.
No, I typed it. I typed the queue name. I think I called it hello.
Right.
I think
the Redis instance. I was just curious. How's?
Oh yeah. No, I mean Redis on the Linux side. I just did. Yes, Redis needs to be running. I'm sorry. That's right. So it was, I'm running Debian, or a derivative of Debian. So I apt-get install Redis. That's it, right? And then now you have Redis.
Okay. Yeah, thank you. I wish I knew about this back, what was it, 2017 or so. I was doing this weird haphazard task queue where I had a bunch of volunteer computers reading from a SQL table parameters for a simulation study. They do their work, and then they mark it complete when they're finished. And so I just took advantage of equal blocking to make sure that only one computer had access to one set of parameters at a time.
Yeah.
But that is less efficient than this.
We did a long time ago. I used to work a lot in finance, and we did I worked with this hedge fund that no longer exists called More Capital in New York, and they used this to do resource scavenging of desktops. So they had a big cluster for running their analytics on, but it was always oversubscribed. There were more people wanted to use it than they had compute cycles, right? And so at night, when the traders went home, they had these really powerful workstations at these trading desks, like lots of them. They were just sitting there. They didn't even turn them off. They're just sitting around. So the traders got this idea, well, we'll just turn on this thing because it's elastic. When they go home, it just they get all of a sudden like, a huge capacity increase in compute. And so and then when they came in the morning to do their work, they just turned off the doRedis stuff on their workstation, and all those jobs just went away. So they used that for quite a while at More Capital.
So what I was thinking is there any particular advantage of Redis over other task queues like Celery or RabbitMQ or the other ones you heard of? Is it Redis just its popularity, or is there some killer feature that makes it much better than these, or are these just alternatives?
Not marketed as a task queue, right? It has a queue in it. It's a minor component of Redis. It's mostly used as a caching system. That's its huge, as like a memcache to replacement, basically. But RabbitMQ RabbitMQ is also just a generic messaging system. Celery is specifically designed to do exactly what I just showed you, right? It's a big complicated system that is written in C and Python that is, does everything I just showed you and like 1,000 times more. The problem with Celery, I don't have a lot of direct experience with Celery, but I've talked to a lot of people who have a lot of experience with it, and it's overcomplicated, bloated, and often crashes. So they hate it. It seems to be a very fragile and complicated program. This thing is incredibly lightweight. So I think that's the main difference. But Celery can do everything I just did. It could do lots more. Like it's got all kinds of crazy stuff in it. But we don't try.
It's the right amount of features. Redis has the right amount of features, and yeah, that makes sense.
For this work, I'd say it's a pretty minimalist program. Yeah,
cool.
Doesn't try to do much.
If everyone's okay, if I want to jump back in, it looks like Michelle is joining us. Michelle, I don't know if you've been affiliated with the group for very long. It's nice to meet you and have you here. I don't know when you got the chance to jump in, but we had a couple of folks asking about the application of analytics and predicting wins in college basketball. I answered as best I could, but I was hoping you could speak a little bit to the applications of predicting who's going to win games. I noticed you work for FanDuel, is that correct? Okay, looks like she might not be with us. Sorry, I just saw she had jumped in here, and it looks like she works for FanDuel, so I thought she might be able to. FanDuel is one of the sites where you can place bets on these kinds of things. They're one of those companies that I think they're kind of have arisen with relaxation and rules about online gambling and interstate commerce, things like that. So I thought she might be able to speak a little bit to that, but I don't know if she's really with us here. So sorry to interrupt.
That's okay. Yeah, and she might just not be able to talk. So, but if you ever want to talk about sports analytics in the future, Michelle, you're more than welcome. All right. Any remaining questions? All right, with our call up, thanks again, Jay and Bryan. If anyone has ideas for talks, please just reach out. You can do a full hour if you want to do a little 20-minute thing like you just saw here. It's really informal, and we'd love to hear what you're working on. And I hope to see some of you at the next cafe. See you, everybody.
Good night. Cheers.
Thank you.
Thank you, guys. Thank you, Jay. Thank you, Brian.